Welcome to the YouTube channel. Let us discuss the velocity and acceleration analysis of mechanisms graphical method. There is module 2, in which today's topic is velocity analysis by instantaneous center method. The topics to be discussed related to instantaneous center methods are: first, let us discuss what is instantaneous center, then how to determine the number of instantaneous centers, which are types of instantaneous centers, then statement and derivation of Kennedy's theorem, steps to locate instantaneous centers, a brief procedure to obtain instantaneous centers for 4-bar mechanism, and brief procedure to obtain the instantaneous centers for slider crank mechanism. So, to explain what is instantaneous centers, let us consider a plane body P having a nonlinear motion relative to another body, a Q. And let us consider point A and point B on body P. So point A is having a velocity VA and point B is having velocity VB respectively in the direction shown. Now, if a line drawn perpendicular to this VA at point A, the body can be imagined to rotate about some point on the line. The center of rotation of the body also lies perpendicular to the direction of VB. So if I take a perpendicular line to vector VB, the intersection of these two lines gives us a center called I. This point I is called as instantaneous center of rotation for a body P. And one more thing is the position of this instantaneous centers keeps changing with respect to the motion of the body. So this instantaneous center is not fixed. If the direction of velocity VA and velocity VB are parallel, in the diagram you can see the velocity of VA and VB are moving in parallel direction. Hence, the perpendiculars what we drawn for this VA and VB will meet at infinity. So, when a body is having linear motion, their instantaneous centers will meet at infinity. That is the thing we can understand from this slide. The how to determine the number of instantaneous centers. The number of instantaneous centers in a mechanism is totally depends upon how many links present in that mechanism. If we consider small n as a number of links and capital N as a number of instantaneous centers, the formula goes like this. So number of instantaneous centers will be equal to number of links multiplied by 1 less than the number of links divided by 2. That is small n multiplied by n minus 1 by 2. If we discuss the types of instantaneous centers, broadly we have two types of instantaneous centers. One is permanent instantaneous centers and the one is primary instantaneous centers and secondary instantaneous centers. The primary instantaneous centers are those which are fixed and permanent. The secondary instantaneous centers are neither fixed and nor permanent. So we can say totally three types of instantaneous centers are available: fixed instantaneous center, permanent instantaneous center, and neither fixed nor permanent instantaneous center. For example, let's consider a 4-bar mechanism. We know the 4-bar mechanism consists of 4 links. So small n will become 4. Hence, the number of instantaneous centers will be 4 into 4 minus 1 divided by 2. By the formula we obtain there are 6 instantaneous centers. So now after drawing a configuration diagram, we can observe this I12 is fixed because that instantaneous center is located on fixed link. Hence I12 as well I14 both are fixed instantaneous center. Then we can consider this I23 instantaneous center and instantaneous center I34 are permanent instantaneous center because this is a pin joint on the 4-bar mechanism. Whereas the instantaneous center 13 and 24 will be neither fixed and nor permanent instantaneous centers. Let us discuss the Kennedy's theorem or now hold Kennedy's theorem. It's also called as three centers in line theorem. The statement of this theorem is if three bodies have motion relative to each other, their instantaneous centers should lie in a straight line. Let us know how it works. Let us consider three bodies. The fixed body is 1 and this is 2 and another body 3 is having relative motion to each other. So here the instantaneous center I12 and I13 are fixed instantaneous centers. So we need to locate at exactly at that point itself. Now let us assume the instantaneous center of link 2 and link 3 be at a point A, that is at this point, that is I23. The point A is a coincident point on link both 2 as well as 3. Considering this point A on link 2, the velocity of A with respect to I12, so if I draw a perpendicular line to this I12, so velocity of A with respect to link 2 will be in this direction. Similarly, if I draw a perpendicular line to I13 line, I will get the velocity of point A with respect to 3, link 3. Since the point A is common, the velocity direction should be same. But here in the diagram we can see the vector is directions are different, which is impossible. Hence, the instantaneous center of the two links cannot be assumed in this position. So it can be seen that I23 should be on a line line joining I12 and I13. Means this I23 must be on the line joining I12 and I13. Hence, for three links to be in relative motion, all three centers should lie in a straight line. That's what the Kennedy's theorem or three centers in line theorem. The steps to locate instantaneous centers are: first, we need to draw the configuration diagram considering suitable scale. Later, we need to identify how many instantaneous centers are to be identified using a equation capital N is equal to small n multiplied by n minus 1 divided by 2, where small n is number of links and capital N is number of instantaneous centers. Then we need to identify the instantaneous centers either by circle diagram or by bookkeeping method. Later, we need to identify the visible instantaneous center and we can locate all instantaneous centers by using Kennedy's theorem. Let us discuss the instantaneous centers of 4-bar mechanism. A 4-bar mechanism has, we know there are 6 instantaneous centers because 4 into 3 divided by 2 gives 6 instantaneous centers. Let us draw a circle, and we need to divide the circle into how many links are available in the mechanism. Right now we have 4 links for 4-bar mechanism. So we will divide the circle into 4 equal parts. Since pin joints are instantaneous centers, for 4-bar pin joints, we can easily identify the 4 instantaneous centers. So we have pin joints at these points. So obviously these 4 will become instantaneous centers. Hence, we have a pin joint joining link 1 and 2 will become I12. A pin joint joining link 2 and 3 becomes I23. Pin joint joining link 3 and 4 gives us I34, and finally I14. So which are the ICs is visible directly, we can join that in circle also, inside the circle also. So these 4 ICs are actual pin joints. So we can draw the visible instantaneous centers, and we came to know IC1 and 2, IC23, IC34, as well as IC14. So we need to join those numbers in the circle also. So to find out the remaining 2 instantaneous centers, we need to apply Kennedy's rule. The IC links 2, 3 and 4 must lie in straight line, because the link 2 and link 3 and link 4, what we have, link 2, link 3 and link 4 are the 3 bodies having relative motion to each other. According to Kennedy's rule, if 3 bodies having relative motion to each other, their IC must lie on straight line. Hence, let us take 2, 4, instantaneous center 2, 4. To the you need to join, if you want the IC24, I am drawing a red line inside the circle. So we need to produce the line IC23 and IC34. So we have I34 and I23 here. So take a line connecting these 2 instantaneous center and produce that line as a first step. Later, this 2, 4 is a common line for another triangle, that is 1, 2, 4. So consider now instantaneous center 1, 2 and instantaneous center 1, 4. Instantaneous center 1, 4. So 1, 4 and 1, 2 are here. Produce a line from 1, 2 and 1, 4 as well. So wherever these 2 line intersects, that point will become the instantaneous center 2, 4. Similarly, to obtain the last instantaneous center, that is 1, 3, now go inside the circle, join a line from 1 to 3. So now this will be the common side for 2 triangles, 1, 2, 3 and 1, 4, 3. So it indicates we need to join a line from I12, I23. So I12 is here in the configuration diagram, I23 is here in this configuration diagram. Just join these 2 and produce certain length line. Now coming to the next triangle, we have I14 and I43. So I14 and I34, we are instantaneous centers are here. Just join these 2 and produce further wherever the intersection of these 2 lines occurs, that is the I13. So now we have found all 6 instantaneous centers. In case of instantaneous center for slider crank mechanism, so we know the slider crank mechanism also consists of 4 links. Hence, there will be 6 instantaneous centers. Again, to make to understand the instantaneous centers, we can draw a circle, and we will divide the circle into 4 equal parts because there are 4 links. In the first diagram, you can see there are 4 divisions. Now we can identify the visible instantaneous centers. That is I12 is a pin joint. So I12 will be the visible instantaneous centers. I23 is also a pin joint. I34 is also a pin joint which connects link 3 with the slider. Whereas the instantaneous center I14 will be at infinity because the link 1 and link 4 is having linear motion to each other. There's a linear motion relative to each other. Therefore, I14 will be goes to infinity, or vertical line, perpendicular line you can take. Now, since we found all the 4 instantaneous centers, we will join a line 1, 2, 2, 3, 3, 4, and 1, 4. To determine 2 more which are unknown, let us take 2, 4 first. So this 2, 4 line is a common side for 2 triangles, that is 2, 3, 4 and 2, 1, 4. So 1, 2, I12, I need to take projection from I12 and I14. So I12 is at this point and I14 will be a vertical line. So I need to draw a vertical line at this junction. Then I23 and I34. I23 is a permanent pin joint or permanent center, and I34 is here. So joining these two instantaneous center and produce a line. So wherever these two line intersects, that gives you instantaneous center 2, 4. Hence, we found all 6 instantaneous centers for slider crank mechanism. Actually, we found 5 instantaneous centers. The one more to be found that is 1, 3. So to find 1, 3 instantaneous centers 1, 3, let us join this 1, 3 line. You need to produce a line from instantaneous center 1, 2 and 2, 3. So instantaneous center 1, 2 is here and instantaneous center 2, 3 is here. Join these two and produce a line. Similarly, we have instantaneous center 3, 4 and instantaneous center 1, 4. So 3, 4 is exactly on the slider and 1, 4 will be at infinity. So I need to draw a perpendicular line to slider. So wherever these two line intersects, there is the location of instantaneous center 1, 3. Now we have found all 6 centers of the 6 instantaneous centers of the slider crank mechanism. So this is the brief procedure about how to locate the instantaneous center, how to find the number of instantaneous centers for 4-bar mechanism and slider crank mechanism using Kennedy's theorem. So by this, we completed the theory aspect of instantaneous centers method. Thank you.